Hi, my name is Lauren Lizak. Today I'm going to be talking about formaldehyde and an environmental health risk assessment related to it. This is for the Florida International University course PHC 6311, and it is with Professor Dhiraj. If you look at slide 1, we're going to talk about what is formaldehyde. Some fast facts about formaldehyde is its chemical name obviously is called formaldehyde, but some synonyms that go along with it are formalin, methylaldehyde, methylene oxide, and those are some common names that you will hear in reference to it. Its molecular formula is CH2O. It is a colorless gas that has a very strong odor. It is sold commercially, and it's sold commercially in names such as methanol and in H2O solution. It is typically used to make resins, textiles, or other chemicals, and it is often used as a disinfectant, as fertilizer, as fungicide, and also as embalming solution. So knowing a little bit about what is formaldehyde, we're going to get into some of its exposures. So, is it hazardous? According to OSHA, which is the Occupational Safety and Health Administration, the airborne exposure limits are permissible. The airborne permissible exposure limit, or the PEL, is from 0.75 parts per million on an average over an 8-hour work shift. If you are exposed to 2.0 parts per million, it is not to at all be exceeded during a 15-minute work period. NIOSH, or the National Institute for Occupational Safety and Health, their recommended airborne exposure limit, which is the REL, is 0.016 parts per million on average over an expansion of a 10-hour work shift, and is 0.1 parts per million are not to be exceeded during a 15-minute work period. So different administrations and agencies have different exposure limits, but they are all still very similar. And the ACGIH, their threshold limit value, or the TLV, is 0.3 parts per million, not to be exceeded at any time at all. So is formaldehyde hazardous? Yes, these agencies and many others would argue that it is very hazardous. On a hazard rating scale, it's rated a 4 for health hazard, a 4 for fire hazard, and a 0 for reactivity, with 0 being the minimal amount of hazard and 4 being severe. So you can see that it is a pretty severe substance, especially in relation to health factors and fire factors as well. So moving on to slide 4, is it a volatile organic compound? Well, yes, it is. Formaldehyde is a carcinogen, and there have been many studies regarding whether it is a carcinogen or not to human beings. Most result in saying that it is, but as of this time, there really may be no safe level of exposure. Formaldehyde is also a mutagen, which means it can induce a genetic mutation. It is very corrosive. When it is come in contact with skin, it can severely irritate and burn, and it causes the eyes a lot of damage as well. Inhalation, which is actually the most prominent method of exposure, can cause nose, mouth, throat, and throat irritation, and it can also cause a buildup in the fluid in the lungs, which is called pulmonary edema. As mentioned previously in the hazard rating scale, it is also a very flammable gas and solution. It's extremely dangerous fire hazard. Formaldehyde is a substance that polymerizes in contact with alkalis, and if it is dissolved in water. Upon heating it, toxic fumes are formed, and it also reacts violently with strong oxidants, strong acids, and strong bases. This, in turn, generates an explosion hazard. Formaldehyde as a substance may polymerize if it is not stabilized, and it decomposes on heating and on contact with acids, bases, and oxidants, which in turn produces flammable formaldehyde. So in all, it is a volatile organic compound. If you go to slide 5, the chemical structure of formaldehyde. Its molecular formula, as mentioned before, is CH2O. It has a boiling point of negative 19.5 degrees Celsius. It has a melting point of negative 92 degrees Celsius, a flash point of 85 degrees Celsius, a density of 1.067, and air density, just for reference, is 1. Its chemical class, as mentioned previously, is a volatile organic compound, and its half-life is about a minute. And you will also see 2 pictures of what the chemical and molecular formula looks like. The one on the bottom is more 2D, and the one on the top, even though I don't have it in rotating form, is its 3D rotation figure of formaldehyde as a chemical structure. So if we move on to slide 6, CDC tests confirm, and this is one case of formaldehyde, that in the aftermath of Hurricanes Katrina and Rita, FEMA trailers were actually used to house victims, and this was in 2005. So FEMA was doing this service to all these individuals who had been displaced and their homes had been lost. But many residents of these trailers were complaining of breathing difficulties, nosebleeds, and persistent headaches. And this was up to 2 years later. So U.S. health officials released tests confirming that potentially hazardous levels of toxic formaldehyde gas were actually within these trailers. 519 trailer and mobile homes were tested, and about 5 times the average home exposure was significantly found in these trailers. And in some trailers, there were levels recorded of up to 40 times the normal exposure. And yes, there is a small normal exposure in everyday life as well as in everyday homes. So moving on to slide 7, formaldehyde exposure routes. So the primary way you can be exposed to formaldehyde, again, as previously mentioned, is by breathing air that contains it. Releases of formaldehyde into the air occur from industries using or manufacturing formaldehyde, such as like wood products, like particle board, plywood, and furniture. Also, automobile exhaust contains formaldehyde, cigarette smoke, paints and varnishes, and even carpets and permanent press fabrics. Indoor air contains higher levels of formaldehyde than outdoor air. Levels of formaldehyde measured in indoor air ranges from 0.02 to 4 parts per million. And formaldehyde levels in the outdoor air range from 0.0002 to 0.006 parts per million. And this is reasonably an acceptable rate because when you're indoors, the air and everything is condensed and compressed in a smaller area, whereas in the outdoors, things can spread apart. In rural and suburban areas, 0.01 to 0.02 parts per million is seen in the outdoor range. However, in the urban areas, the measurement shrinks a little bit. So 0.01 to 0.02 is the urban area range. The highest potential exposure occurs in the formaldehyde-based resins industry, typically. So in the air, the daily exposure resulting from breathing is about 1 milligram a day of formaldehyde, with very few exposures at a little more than 2 milligrams per day and a maximum at about 8 milligrams per day. Occupational exposure, though, does drastically contribute to the total exposure number. Concentrations of around 60 to 130 milligrams have been measured in mainstream cigarette smoke For a person smoking 20 cigarettes per day, this would indefinitely lead to an exposure of 1 milligram per day of formaldehyde, which is very significant. Except for accidental contamination of water with formaldehyde, concentrations in drinking water can be expected to be less than 0.1 milligrams per liter. But intake from this source can therefore be considered negligible, which really means that formaldehyde contamination water is highly unlikely. Formaldehyde does occur naturally in foods, and foods may be contaminated as a result of fumigation, such as grains in a field. It can also be contaminated in cooking, such as using a combustion product. And release from formaldehyde, resin-based tableware can also cause a small contamination in food. Formaldehyde has been used as a bacteriostatic agent in some foods, such as cheese. And other exposure routes, cosmetic products containing formaldehyde, formalin, and paraformaldehyde may come into contact with hair, such as shampoos and hair preparations such as straighteners have been a big bone of contention in the formaldehyde studies. Skin, it can be a cosmetic product such as deodorants, bath products, skin preparations, and lotions. You can come into contact with formaldehyde. Your eyes, such as using mascara, eye makeup, can cause some cosmetic exposure. Oral mucosa, such as using mouthwashes and breath fresheners. Vaginal mucosa, such as vaginal deodorants. And even nails, such as cuticle softeners and nail creams and lotions, can contain some small amounts of formaldehyde. But exposures from most of these sources is localized, although some formaldehyde is available for inhalation, such as from shaving creams or any sort of fumes from, say, the nail polish remover. At levels to which humans may be exposed, though, adverse effects are most likely to be observed primarily following inhalation, not typically through any sort of food or cosmetic absorption or exposure. But it has been shown experimentally that effects on organisms, such as mammals, are more closely related to concentration than to the accumulated total dose, meaning that the concentration in a small amount is more closely related to the bigger effects as opposed to the total dose, since the half-life of formaldehyde is very short. And again, this is due also in part to the rapid metabolism and high reactivity and water solubility of formaldehyde. So moving on to slide 8, exposure routes and models. So one of the main exposure routes and models is a conceptual, is shown here, is a conceptual representation of physiologically based pharmacokinetic model, or a PBPK model, which we've been learning about this semester. And this model is used for a hypothetical chemical substance. However, through many studies that I've observed, the PBPK model has been used to study formaldehyde. So the Environmental Protection Agency, or the EPA, put out an integrated risk information system assessment, or IRIS they called it, which they look at many different, any sort of risks that are recognized through the EPA, and they throw it into the system and assess it. So in formaldehyde, the IRIS system looked at formaldehyde toxicokinetics, carcinogenic models of action, pharmacokinetic models, and biologically based dose response models. And those were all examined as actual resulted models that were used in this IRIS risk assessment. So these are models that have been studied. The Agency for Toxic Substances Disease Registry, or the ASTDR, they use to identify and to examine formaldehyde. They use the physiologically based pharmacokinetic as well as the pharmacodynamic models. So the PBPK and the PBPD models are often used through the ASTDR. So these models are the most prominent ones that are used frequently to assess formaldehyde through their exposure routes. The PBPK models use mathematical descriptions of the uptake and disposition of chemical substances to quantitatively describe the relationships among critical biological processes. And that's the actual definition of PBPK models. So most of these models are biologically and mechanistically based and can be used to extrapolate the pharmacokinetic behavior of chemical substances from high to low dose. So it kind of compares at a high dose what may happen versus at a low dose what may happen. It also looks at the from root to root between species and between subpopulations within the species. So what are the different effects that it may have on different species? So moving on to slide 9, scientific literature and resources. So there are tons and tons of sources available regarding dose response. The most reliable information is found from government websites. And again, this is because through these government websites, this is where the most studies have been done with the most reliable test results, or the most reliable studies providing the most reliable test results. So some sources that are very interesting to read about formaldehyde and also are reliable are the United States Consumer Product Safety Commission, U.S. Department of Health and Human Services, and their Agency for Toxic Substances and Disease Registry, U.S. Environmental Protection Agency and their Integrated Risk Information System, the National Institute of Technology, the National Cancer Institute, the U.S. Food and Drug Administration, Occupational Safety and Health Administration, National Toxicology Program, the CDC, or their Centers for Disease Control and Prevention, and the National Institute of Health, their National Library of Medicine. And these are all just a tip of the iceberg number of reliable sources to find scientific literature and other sources. So moving on to slide 10, quantifying risk approaches. So if you look at this graph or this table that I have here, it is just a screenshot of some pollutants that are examined and what they look like when they are classified or quantified as a risk. So again, this is just an example. You can see that formaldehyde is third up from the bottom, and those are two organizations that have looked at it and the different factors between them. So then going further, biomarkers, which are usually used to quantify risk, they're broadly defined as indicators signaling events in biologic systems or samples, and they have been classified as markers of exposure, markers of effect, and markers of susceptibility. The preferred biomarkers of exposure are generally the substance itself, such as formaldehyde, or substance-specific metabolites in readily obtainable body fluids or excreta. Biomarkers of effect are defined as any measurable biochemical and physiologic and or alteration within an organism that, depending on magnitude, can be recognized as an established or potential health impairment or disease. So formaldehyde is a simple one-carbon molecule and is rapidly absorbed and metabolized by animals, including humans. A thorough review of the available literature, most of them typically failed to produce any reliable biomarkers of exposure to formaldehyde, which is kind of a disappointing result. Formaldehyde is rapidly absorbed by the inhalation and oral routes of exposure, and once absorbed, there are 4 major metabolic pathways associated with formaldehyde metabolism, with the metabolism to formate and CO2 the most heavily used, the routes of, pathways associated with metabolism. And attempts have been made to determine if either blood or urinary levels of formaldehyde or formate could be used as potential biomarkers of exposure, and again, with disappointing results. So moving on to slide 11, these are actually just an extension of the previous slide. These are, in a visual, the metabolic pathways of formaldehyde biotransformation. So again, there are 4 major metabolic pathways. The first, as we had previously mentioned, is the metabolism to formate. So you can see, and that's a very extensive pathway, but number 1 is the metabolism to formate. Number 2 is binding to tetrahydrofolate. Number 3 is the non-enzymatic reactions with sulfonyl groups and urea. And the 4th is DNA and protein cross-linking. And again, these are the 4 visual metabolic pathways of biotransformation. So let's get into some of the at-risk populations, or some of the people that would be more predominantly exposed to formaldehyde. So on a very basic level, workers in mortuaries, hospitals, medical laboratories, and or other places that make or use formaldehyde or formaldehyde-containing products may be exposed to higher levels of formaldehyde than the general public. And again, this is a very obvious statement, but these specific places are the ones that deal more predominantly with the formaldehyde itself. So these workers may breathe in formaldehyde or have skin contact with it. If formaldehyde is released to the environment, it will be degraded into the air. It will escape as a gas from dry and moist soils and from water surfaces. But because it also dissolves in water, formaldehyde will move with water through soils. It is expected to biodegrade readily in soil and water, however, and it will not build up in aquatic organisms. So again, the air is most likely the route of exposure through inhalation. So in addition to healthcare professionals and medical lab technicians, groups who are also at potentially high risk include, and again, mortuary workers were one of them, but teachers and students who handle biological specimens preserved with formaldehyde or formalin. And so these would be when you're learning in, a biology course, when you're doing dissections on frogs or pigs, that would be when the teachers and the students would be exposed to the formaldehyde. So some worker protection measures. There are many worker protection measures that are set aside. They specifically are identified through OSHA, obviously, and these measures are very detailed typically. So airborne concentrations of formaldehyde above 0.1 parts per million can cause irritation of the respiratory tract. So the severity of irritation intensifies as concentrations increase. And again, the provisions that OSHA has set up are typically the standard for all employers. And these employers must do the following. So the first one is to identify all workers who may be exposed to formaldehyde at or above the action level through initial monitoring and determining their exposure. Second, reassign those workers who suffer significant adverse effects from formaldehyde exposure to jobs with significantly less or no exposure until their condition improves. Reassignment may continue for up to 6 months until the worker is determined to be able to return to the original job or to be unable to return to work at all, whichever comes first. The third is to implement feasible engineering and work practice controls to reduce and maintain worker exposure to formaldehyde at or below the 8-hour limit. If these controls cannot reduce the exposure, employers must provide workers with respirators. In other words, if the employer cannot get rid of these exposures, they need to provide a better way to breathe and a safer way. Employers must label all mixtures or solutions composed of greater than 0.1% formaldehyde and materials capable of releasing formaldehyde into the air at concentrations reaching or exceeding 0.1 parts per million. For all materials capable of releasing formaldehyde at levels above 0.5 parts per million during normal use, the label must contain the words, in quotations, potential cancer hazard. And again, these are all defined by OSHA. And these identified measures actually continue on to the next slide, slide 14. So the next one OSHA identifies is for the employers to train all workers exposed to formaldehyde concentrations of 0.1 parts per million or greater at the time of initial job assignment and whenever a new exposure to formaldehyde is introduced into the work area. So these trainings also need to be repeated annually so as to keep everybody up to date and in case anything changes throughout the year. Employers need to select, provide, and maintain appropriate personal protective equipment or PPEs. They need to ensure that workers use these PPEs such as impervious clothing, gloves, aprons, and chemical splash goggles to prevent skin and eye contact with formaldehyde. And again, going back to any sort of individual exposed, even to teachers and students, in those classes you are often taught and should be taught to use all these appropriate personal protective equipment. The employers must provide showers and eye wash stations if splashing is likely. They must provide medical surveillance for all workers exposed to formaldehyde at concentrations at or above the action level or exceeding the action level, for those who develop signs and symptoms of overexposure, and for all workers exposed to formaldehyde in emergencies. Record-keeping requirements are also a hugely important part for employers, and OSHA sets this aside as well. So not only are these a protection measure, but they're a requirement that you need to retain. So employers are required to do the following regarding worker exposure records. So if you are exposed, they need to retain exposure records for 30 years. They need to retain medical records for 30 years after employment ends. They need to also allow access to medical and exposure records to current and former workers or their designated representatives upon request. So in case you have a new worker or an old worker or a new place of work where individuals need to provide proof of exposure or non-exposure. So moving on to slide 15, the nature of the material. So formaldehyde is known to be a human carcinogen based on sufficient evidence of carcinogenicity from studies in humans and supporting data on mechanisms of carcinogenesis. Formaldehyde was first listed in the second annual report on carcinogens in 1981. As reasonably anticipated to be a human carcinogen based on sufficient evidence from studies in experimental animals. So this means that in 1981 we were reasonably sure that formaldehyde was a carcinogen. But since that time, additional cancer studies in humans have been published, and the listing status was then changed from reasonably anticipated to a known human carcinogen. Officially, it was provided in the 12th report on carcinogens in 2011. So again, in 2011, this is when formaldehyde was now considered a known carcinogen to humans. Epidemiological studies have demonstrated, again, a causal relationship between exposure to formaldehyde and cancer in humans. Causality is indicated by consistent findings of increased risk of nasopharyngeal cancer, sinonasal cancer, and lymphomatopoietic cancer. Specifically myeloid leukemia among individuals with higher measures of exposure to formaldehyde, which cannot be explained by chance, bias, or confounding, meaning that all of these different types of cancer could not in any other reasonable fashion be explained off as not being caused by formaldehyde through chance, bias, or confounding. So different mechanisms by which formaldehyde cause cancer are not completely understood fully. Like I had mentioned previously, it is a known carcinogen, but it is not fully understood. They're not completely understood, and most likely it does involve several modes of action. So formaldehyde exposure is associated with key events related to carcinogenicity, such as DNA reactivity, gene mutation, chromosomal breakage, epigenetic effects such as binding to lysine residues of histones, different oxidative stress and cytotoxicity, induced cellular proliferation, and all these other big chemical terms that deal with and prove that there is not just one specific mode of action, but rather there are many, and it's very hard to nail down or specifically study why formaldehyde or through which mode of action formaldehyde is causing cancer in humans and or other mammals. Formaldehyde is direct-acting genotoxic compound. It has given positive end results for almost all genetic endpoints in bacteria, yeast, fungi, plants, insects, nematodes, cultured mammalian cells, meaning that in all of these entities and these living organisms, formaldehyde has been proven as a direct-acting genotoxic compound, meaning that it does have the ability to cause cancer. So moving on to slide 16, governmental regulations. There are many regulations set aside by the government, and so I'm going to get into the multitude of what they are. So regulations that the government have implemented are, so first the Coast Guard. In the Coast Guard, the Department of Homeland Security, they detail procedures for shipping formaldehyde solution, and different incompatible chemicals to formaldehyde. There are minimum requirements that have been established for safe transport of formaldehyde solutions on ships and barges. The Consumer Product Safety Commission, or the CPSC, formaldehyde and products containing 1% or more formaldehyde are considered strong sensitizers and must display a warning label. So then for the Department of Agriculture, or the USDA, they have set limits, and these limits have been established for the amount of residual formaldehyde in inactivated bacterial products and killed virus vaccines. In the Department of Housing and Urban Development, or HUD, all plywood and particle board materials bonded with a resin system or coated with a surface finish containing formaldehyde shall not exceed the following emission levels when installed in manufactured homes. And these levels are 0.2 parts per million for plywood, 0.3 parts per million for particle board. Manufactured homes must predominantly display a notice which provides information on formaldehyde sources, levels, health effects, and remedial actions to reduce indoor levels. And again, a big part of these regulations were all in response to FEMA, not necessarily in response, but FEMA, again, kind of went against it involuntarily. The DOT, or the Department of Transportation, their regulations said that formaldehyde, formalin, and paraformaldehyde are considered hazardous materials, and special requirements have been set for marking, labeling, and transporting these materials as set aside in 49 CFR 172, which is just the regulation number and body. Okay, so then next we have the EPA. So there are multiple acts that the EPA has set aside. So in the Clean Air Act, for clean fuel vehicles, formaldehyde emission limits have been established for various classes of clean fuel vehicles. Control of emissions from new and in-use highway vehicles and engines, such as formaldehyde emission limits, have been established for various classes of vehicles. In mobile source air toxic, formaldehyde is listed as a mobile source air toxic for which regulations are to be developed. Under the National Emission Standards for Hazardous Air Pollutants, formaldehyde is listed as a hazardous air pollutant. In the new source performance standards, manufacturing of formaldehyde is subject to certain provisions for the control of volatile organic compound emissions. In the prevention of accidental release, threshold quantity equal to 15,000 pounds is the prevention, and regulation of fuels and fuel additives under this act. Under reformulated gasoline certification requirements, formaldehyde emission levels must not be exceeded at all. Under the urban air toxics strategy, formaldehyde is identified as one of 33 hazardous air pollutants that present the greatest threat to public health in urban areas. And in the Clean Water Act, formaldehyde and paraformaldehyde are listed as hazardous substances. Under the Comprehensive Environmental Response, Compensation, and Liability Act, formaldehyde's reportable quantity, or the RQ, is equal to 100 pounds, and paraformaldehyde reportable quantity is equal to 1,000 pounds. In the Emergency Planning and Community Right to Know Act, toxic releases inventory, listed substance subject, such as formaldehyde, is subject to reporting requirements. Reportable quantity is, again, 100 pounds. The threshold planning quantity, or the TPQ, is now at 500 pounds. So the Resource Conservation and Recovery Act, formaldehyde is listed as hazardous waste. Waste codes for which the listing or this chemical is based wholly or partly on the presence of formaldehyde. It is then in turn listed as a hazardous constituent of waste. And again, that was a lot, but those were all under the EPA and all of their acts. So then under the FDA, numerous formaldehyde-based chemicals may be used as components of adhesives and coatings and packaging, transporting, or holding food, provided that conditions prescribed in this certain regulation are met. And numerous formaldehyde-based chemicals may be safely used as articles intended for use in contact with food, provided that conditions prescribed in, again, this very same regulation are met. Numerous formaldehyde-based chemicals may be used in the production of paper products intended for use in producing, processing, preparing, treating, packaging, transporting, or holding food, provided that conditions prescribed in this regulation are met. Formaldehyde and formaldehyde-based chemicals may be used as adjuvants, production aids, and sanitizers that come in contact with food, provided that conditions prescribed in this regulation are met. Formaldehyde-based ion exchange resins may be used in the treatment of food. Formaldehyde may be safely used in the manufacture of animal feeds. Formalin containing approximately 37% formaldehyde gas by weight can be used in environmental waters for the control of fungi and parasites for certain finfish and shellfish. So then, under Mine Safety and Health Administration, engine exhaust from mobile diesel-powered transportation equipment must be diluted with air so that the mixture contains no more than 0.001% by volume of aldehydes circulated as equivalent formaldehyde. Under OSHA, or the Occupational Safety and Health Administration, their regulation says that while this section accurately identifies OSHA's legally enforceable PELs for this substance in 2010, specific PELs may not reflect the more current studies and may not adequately protect workers, meaning that OSHA has the ability to keep them updated as things change, and that previous regulations may not always cover the current standard. So permissible exposure limit, or as previously mentioned, the PELs are set aside. And again, as mentioned in the very first slide, OSHA sets aside a certain level of regulations for certain time limits that are to strictly be adhered to. Comprehensive standards have been developed for occupational exposures to formaldehyde gas, its solutions, and materials that release formaldehyde. These standards identify the permissible exposure limits and prescribe requirements for monitoring exposures using respiratory protection, conducting medical evaluations, housekeeping, and other activities. And again, we had previously gone through a good portion of OSHA's regulations and requirement to their employers. So requirements for preventing or minimizing the consequences of catastrophic releases of toxic, reactive, flammable, or explosive chemicals, and the threshold quantity for formaldehyde is also explained in their regulation. And then finally, some guidelines. The American Conference of Governmental Industrial Hygienists, or the ACGIH, they regulate the threshold limit value ceiling, or the TLVC, as 0.3 parts per million. This is listed as a suspected human carcinogen, meaning that this is the absolute highest level or the highest limit of formaldehyde that they have put into their guideline. The National Institute for Occupational Safety and Health, or NIOSH, their recommended exposure limit is 0.016 parts per million. An immediately dangerous to life and health limit, or the IDLH, is 20 parts per million, meaning that this is no time sensitive, this is a very time sensitive exposure, meaning that it does not have a length of time. It is immediate exposure. So if any sort of individual or organic person or human or animal is exposed at 20 parts per million, it is life-threatening immediately. Ceiling is recommended. The ceiling exposure limit is 0.1 parts per million, and is listed then as a potential occupational carcinogen. So if we move on to slide 17, minimizing exposure. So we've previously discussed many ways that individuals and other mammals can be exposed, but now we need to get into how do we actually minimize the exposure of formaldehyde. So the EPA recommends the use of exterior grade pressed wood products to limit formaldehyde exposure in the home. These products emit less formaldehyde because they contain phenol resins, not urea resins. Pressed wood products include plywood, paneling, particle board, and fiber board, and are not the same as pressure-treated wood products, which contain chemical preservatives and are intended for outdoor use only, not indoor use. So to make sure that you are adhering to this before purchasing pressed wood products, including building materials, cabinetry, and furniture, buyers should ask about the formaldehyde content of these products. Formaldehyde levels in homes can also be reduced by ensuring adequate ventilation, moderate temperatures, and reduced humidity levels through the use of air conditioning and humidifiers. And again, that is specifically what the EPA recommends to minimize exposure to formaldehyde. Specifically for the CDC, they recommend avoiding tobacco smoke, since formaldehyde is a component of tobacco smoke, as again previously discussed. Avoid smoking in enclosed spaces such as inside the home or car in order to limit the exposure to children and other family members. Excuse me. It is also recommended to keep your house ventilated. Formaldehyde is released into indoor air from construction materials and a variety of consumer products, again, such as the cosmetic products previously discussed. Formaldehyde levels can be reduced by bringing fresh air into the home, opening windows, opening doors, limiting the use of pressed wood in homes or by sealing uncovered pressed wood products. Families should keep houses well ventilated by opening windows or using ventilation fans when levels are known to be high. And then lastly, the CDC recommends washing new clothes since some permanent pressed fabrics emit formaldehyde. Washing these new clothes before wearing them will usually lower the amount of formaldehyde released from permanent pressed fabrics and in turn reduces exposure to families. And then lastly, the Agency for Toxic Substances and Disease Registry recommends, in conjunction with the CDC, to again not smoke, especially not indoors. They recommend again opening windows as much as possible to let in the fresh air, trying to keep the temperature inside your home at the lowest comfortable setting, and they say that it is beneficial to prevention, as well as running the air conditioner or dehumidifier in general to control mold. Also, spend as much time outdoors in fresh air as possible. It's important for families with children, elderly people, or those with chronic diseases such as asthma to do so and get fresh air into their system. The ASTDR recommends that to control mold, you should fix water leaks that mold can be attracted to, and to additionally clean away any mold you may see or smell with detergent and water. And this is a very time-sensitive issue, and you need to catch mold at its earliest sighting. So moving on to slide 18, the comprehensive dose description. It is very difficult to understand in lay terms, the dose description of formaldehyde, but in its most easiest understanding, formaldehyde is a colorless gas, and it's colorless, which makes it very difficult to identify, but it does have a very pungent, suffocating odor at room temperature, and this is likely, when you're in biology class, what you smell when you are doing a dissection, which is how you know that you are inhaling formaldehyde. So though formaldehyde is very difficult to understand, a part per million in air represents a fraction of volume of air occupied by formaldehyde. So again, we go back to the idea that 1 part per million is air, and 1 part per million is equivalent to 1 unit volume of formaldehyde per 1 million units of air. So formaldehyde's part per million are very, very low. So just in terms of understanding how prevalent formaldehyde is in air in a very typical situation, it's very, very low. But again, if you smell it, because it is pungent, you are likely to know, or at least realize, that something is not particularly right. And then lastly, though a couple of these resources were outlined previously, there are many, many reliable resources if you choose to find out more information. And again, these resources are very detailed. It is not difficult to find any sort of information you are looking for in terms of looking for formaldehyde. Formaldehyde is, though not exclusively studied in its entirety thus far, what has been studied is very well outlined. And so these are some of the sources and organizations that are very prominent and reliable to promoting and educating the community about formaldehyde. So I have used more than 10, but these are a couple of the top 10 that are very prevalent. And they are in no specific identified order. So you've got the U.S. Consumer Product Safety Commission, U.S. Food and Drug Administration, the Occupational Safety and Health Administration, the Federal Emergency Management Agency, the U.S. Environmental Protection Agency, the Centers for Disease Control and Prevention, the National Institute for Occupational Safety and Health, the U.S. Agency, the U.S. Health and Human Services, the Agency for Toxic Substances and Disease Registry, and lastly, the American Cancer Society. And again, there are many other reliable sources, and there are many studies that have been done as well, but these are just a couple of the top 10 sources that I have used specifically. And so then lastly, on slide 20, I just want to thank you all for bearing with me through this lengthy environmental risk assessment on formaldehyde. I appreciate you sticking with me, and thank you for watching. Bye.